So this is going to be for reassessment 7. I have a question that says, a spring gun has a spring constant of 28 newtons per meter that is used to shoot a 56-gram ball horizontally. Initially, the spring is compressed by 18 centimeters. The ball loses contact with the spring and leaves the gun while the spring is still compressed 12 centimeters. What is the speed of the ball when it hits the ground 1.4 meters below the spring of the gun? So, I drew a little picture to show the spring and where the ball goes horizontally. And we're given the K of 28 newtons per meters, a mass of 56 grams, which is converted to 0.56 kilograms, a height of 1.4 meters, an X of 18 centimeters, and then an X of 12 centimeters. And to subtract that, you get 6, and convert that, you get 0.6 meters. So then we're looking for velocity. So we'll need to use potential spring energy before the gun has been shot and then is converted to kinetic energy, which is where we will get our velocity from. So we're going to have the potential energy of a spring, which is 1/2 K of the spring times your S squared, and K is equal to 1/2 mv squared, which is kinetic energy. These will be equal to each other because the energy converts to one another. And so we're going to have 1/2 Ks squared is equal to 1/2 mv squared. And we know everything but our v. And this is going to be our initial velocity. So initial velocity is going to be 1/2 Ks squared over 1/2 the mass. And then we can plug in our values, and we're going to get 1/2 times 28, because that's our spring constant, 0.06 meters squared, because that's the distance that changed from the ball. No, that's the distance of the spring that changed. And then divide that by 1/2 times 0.056, which is going to be the mass. And when you do that, you're going to get 1.34 meters per second. Yeah, I think that's right. And then flip this over. And so to find the final velocity, we're not given any time. So I used a kinematic equation that I remembered from high school, which is the V final squared equal to the V initial squared plus the 2 times GH. And then when you solve that out, it's going to be V is equal to the square root of V initial squared plus 2GH. And so that way we know everything to find our V final. And we're going to plug in 1.34 squared for our initial, because that's what we solved in the beginning, plus the 2 times the 9.8, which is our gravitational constant, or gravitational force. And then 1.4, which is the height. And that is going to give you a final velocity of 5.41 meters per second, meaning the ball at the height of 1.4 meters, when it hits the ground, 1.4 meters below the spring of the gun, is that meters per second.